Hello everyone, let us discuss about matrix inversion method today. That is how to solve x and y, x, y, z from the given three equations by using matrix inversion method. First we will convert all these equations into matrix form. That is coefficient matrix. First we write that is denoted by A. So A is equal to, we write A is equal to, we will write all the coefficients of x, y, z in form of rows. So in the first equation we have 3, 4, 5. That is 3, 4, 5 in the first row, and in the second equation we have 2, minus 1, 8. That we write in the second row. Next, in the third row we have in the third row we have 5, minus 2 and 7. These three we will write in the third row. Now next we write variable matrix. In variable matrix we write variables of x, y, z. In variable matrix it is a single column matrix. Next we write constant matrix, that is B is equal to all the constants we will write 18, 13, 20. We have written constant matrix. So we converted all the given three equations into matrix format. Now after this we have to find out determinant of A, det A. We denote it by det A. So det A, when we find out, first element we will take 3. When you take 3, we have to remove first row and first column. That is where 3 is present. In which row 3 is present, which column 3 is present, that row and column should be eliminated. Then the remaining elements are minus 1, 8, minus 2, 7. So we will take these elements along with 3. So 3 into minus 1, 8, minus 2, 7 we will take. After that, in the similar way, second element, that is 4. But when you take second element, we have to take minus 4 into, again same procedure we follow, that is row and the second column. First row and second column we eliminate. Then we will be having 2, 8, 5, 7. So we will write these elements within the determinant. That is minus 4 into 2, 8, 5, 7 plus 5. Third element 5 into 5 is present in first row, third column. So first row and third column should be eliminated. In the remaining elements we have to take along with 5. That is what are left over there: 2, minus 1, 5 and minus 2. 2, minus 1, 5, minus 2 will be left. Now we have to do the calculation. 3 into, what should be done? Minus 1 should be multiplied to 7. So becomes minus 7. And then we should multiply minus 2 to 8. Minus 2 to 8. So what we get? Minus 16. 2 into minus 8. Minus 16 we get. So it is minus of minus 16. Then minus 4. After this we have minus 4 into, same again we have to multiply 2 into 7, we should multiply, that is 14. Again 5 into 8 we should multiply, that is 40. 14 minus 40 it is going to be 14 minus 40. Then again plus 5. 5 into 2 into minus 2 should be multiplied, which is minus 4, minus of 5 into minus 1 should be multiplied, which is minus 5. So finally what we get here? Now in the next step we get 3 of minus 7 plus 16. Minus 7 plus 16 is how much? Minus 7 plus 16 is plus 9. 3 into plus 9. Minus 4 into 14 minus 40. 14 minus 40 is minus 26. Plus 5 into, it is going to be minus 4 minus of minus 5. Minus 4 minus of minus 4, 5 is plus 1, because minus 4 plus 5 is 1. So now it is 3 9s are 27 plus minus 4 into minus plus 4 into 26, 104. Then plus 5 into 1, 5. Now the overall result is 27 plus 104 plus 5 is 136. So this is what? Determinant of A. We got determinant of A. Now determinant of A is not equal to 0. Then further solution is possible. We can find out the solution. So further what we have to do, once if we get determinant of A, we have to find cofactors of the given elements. That is cofactor of A. So to find out cofactor of A, for every element of A, we have to find out cofactors. So first we will find out the cofactor of first element, that is 3. So we write cofactor of 3. Cofactor of 3, that is equal to 3 is present in first row and first column. So we should take minus 1 whole to the power of 1 plus 1. When we find out cofactor, minus 1 whole to the power of 1 plus 1 into, again same procedure like how we did before. First row and first column should be deleted and the remaining elements we have to take. What are the remaining elements? Minus 1, 8, minus 2, 7. So minus 1 should be multiplied to 7, minus 2 should be multiplied to 8 in the same way. So minus 1 into 7, minus 7, minus of minus 2 into 8, minus 16. So it is going to be in the same way like before, minus 1 whole to the power of 2 plus 1 into minus 7 plus 16 is plus 9. So minus 1 whole to the power of 2 plus 1 plus 9, plus 1 into plus 9 is 9. So the result is going to be 9 here. We already got before, that is 9. So here we get cofactor of 3 as 9. Hope you all understood how to do it. Now cofactor of 4. Cofactor of 4 is equal to, cofactor of 4 is equal to minus 1 whole to the power of 4 is present in first row second column, so it is 1 plus 2, minus 1 whole to the power of 1 plus 2 into, like before same we follow. So 2, 8, 5, 7 we will be having. So we have to multiply 2 into 7 and 5 into 8. Same way when we found determinant, in the same way we did here also we have to follow the same. So 2 sevens are 14 minus 5 eights are 40. So it is going to be minus 1 whole to the power of 3 minus 1 into 14 minus 40 minus 26. Minus 1 into minus 26, which is 26. So that is cofactor of 4. Now in the same way we have to find cofactor of 5. Cofactor of 5 is equal to, 5 is present in first row and third column, minus 1 whole to the power of 1 plus 3 it is, into, now first row and third column should be eliminated, so that we will be having 2 minus 1, 5 minus 2. So 2 into minus 2, minus 4, minus of minus 5. So that is going to be minus 1 whole to the power of 4, which is plus 1, into minus 4 minus of minus 5 is minus 4 plus 5, which is 1. So it is going to be 1 into 1, that is 1 into plus 1. Final result is again 1. Now again next in the similar way we have to find out cofactor of 2 is equal to minus 1 whole to the power of, that is there in second row and first column, so 2 plus 1, minus 1 whole to the power of 2 plus 1 into, so what should be multiplied now? The second row and first column should be eliminated, then we'll be having 4, 5, minus 2 and 7. So now we have to multiply 4 sevens are, same procedure we have to follow like before. So 4 into 7, 28, minus minus 2 into 5. So minus of minus 10 it is going to be. So that is equal to minus 1 whole to the power of 3, which is minus 1, into 28 minus of minus 10 is 28 plus 10. 28 plus 10 is 38. So minus 1 into 38 is minus 38. So that is cofactor of 2. We got cofactor of 2 as 38 minus 38. Now we have to find cofactor of minus 1. Cofactor of minus 1 is present in second row, second column. So minus 1 whole to the power of 2 plus 2. So minus 1 whole to the power of 2 plus 2 into that row and column should be eliminated. Then we'll be having 3, 5, 5, 7. So 3 sevens are 21, 5 5 is 25. So what we get here, multiply 3 into 7, 21 minus 5 into 5, 25. 21 minus 25. So that is going to be minus 1 whole to the power of 4, which is even number. So 1 into 21 minus 25 is minus 4. So the result is going to be minus 4. Now similar way we have to find out cofactor of 8. We should also find cofactor of 8. So how we find cofactor of 8? Same. So that is present in second row, third column. So minus 1 whole to the power of 2 plus 3 into, now third column and second row should be eliminated. Then we'll be having 3, 4, 5 minus 2. 3, 4, 5 minus 2. So the result is going to be, you have to multiply like this. What? 3 into minus 2, which is minus 6, minus of 5 into 4. So minus 20. So the result is going to be minus 1, because minus 1 whole to the power of 5 is minus 1 into minus 26. Minus 1 into minus 26 is minus into minus plus. So it is going to be plus 26. Hope you all understood all these cofactors, but still we need to find out some more cofactors. So what cofactors? Again we have to find after this. We have to find cofactor of 5 now. Cofactor of 5. Cofactor of 5 is equal to, 5 is present in first column and third row. So 3 plus 1. Minus 1 whole to the power of 3 plus 1 should be taken. Minus 1 whole to the power of 3 plus 1 into, what should be taken? This row and column should be eliminated. Then we'll be having 4 minus 1, 4, 5 minus 1, 8. So it is going to be, 4 8 is 32, minus of 1 into 5 minus 5. So our result is going to be minus 1 whole to the power of 4 is 1 into 35, 32 minus of minus 5 is 32 plus 5. 32 plus 5 is 37 plus 37. Similarly, we should also find cofactor of minus 2. So minus 2 is present in second column, third row. So it is going to be 3 plus 2. So this row and column should be eliminated. Then be having 3, 5, 2, 7. So we have to write here minus 1 whole to the power of 3 plus 2 into, what is left? 3 8 is 24, minus, we have 1 into 5, 5. Oh, 2 into 5, 10. So it is 24 minus 10. So what we get? Minus 1 whole to the power of odd number, which is minus 1. Minus 1 whole to the power of 3 plus 2 is minus 1 again. Minus 1 into 24 minus 10 is 14. So minus 14, result is going to be minus 14. Now cofactor of 7 is equal to, it is present in last row, last column, third row, third column. So minus 1 whole to the power of 3 plus 3 into, now what it is left, 3 4 minus 3 4 2 minus 1, 3 4 2 minus 1, so 3 into minus 1, so it is going to be into 3 minus 3, 2 4s are 8, so minus 3 minus 8, minus 3 minus 8, so it is minus 1 whole to the power of 6 is 1, 1 into minus 3 minus 8 minus 11, so 1 into minus 11 is minus 11. So like this we can find out all the cofactors of elements. Now we have to write cofactor matrix of A. After we are finding all the cofactor elements, we have to find cofactor matrix of A. In this we will write all these cofactors. All these cofactors we will write in the matrix, that is 9, 26, then 1, 9, 26, 1. Then the remaining cofactors are minus 38, minus 4, and then next cofactor 26, next 37, minus 14, minus 11. So this is called cofactor matrix of A. Once after we are finding all the cofactors, we have to write in the matrix, that is what cofactor matrix. After this we have to find adjoint A. Adjoint A is equal to, it is transpose of cofactor matrix. Once we know cofactor matrix, just change the rows and columns, interchange the rows and columns, we get adjoint A. So what we have here, first row 9, first column we have 9, minus 38, and then 37. That should be written as first row. First column we are writing it as first row, and the second column is what, 26, then minus 4, and then minus 14. Now take third column is 1, then 26, and then minus 11. So what I did here, I interchanged all the rows and columns of cofactor matrix, then we got adjoint matrix of A. Once we know adjoint A, then we have to use the formula to find A inverse. A inverse is equal to what, 1 by, that is adjoint A by det A, adjoint A by det A. We use this formula to find out A inverse. Try to remember it. A inverse is equal to adjoint A by det A. So let us find out A inverse now. So A inverse is equal to, how can we write it? 1 by oh, it is not 1 by 36. It is 1 by 136, because det A we got 136. So let us write det A value also here. Det A value we got 136. Now we got det A. We substituted det A value 1 by 136 into, now we have to write adjoint A. Adjoint A already we got, that is 9, minus 38, 37, 26, minus 4, minus 14, then 1, 26, minus 11. So we got adjoint A and A inverse also. So A inverse is equal to adjoint A by det A. By using that formula we wrote A inverse. Now we have to find X. X is equal to formula A inverse into B. We have to multiply A inverse and B, constant matrix. So we use this formula to find out A inverse now, X now, variable matrix. Hope everybody know how to multiply two matrices, multiplication of two matrices. To find out X, we multiply A inverse to constant matrix. Now let us see how to multiply. X is equal to A inverse is 1 by 136 into 9 minus 38, 37, then 26 minus 4 minus 14, then 1, 26 minus 11 into B we have to write. In B what we have? 18, 13, 20. Right. Now we have to multiply here. Hope everybody know how to multiply the matrices. 9 should be multiplied to 18, 38 should be multiplied to 13, 37 should be multiplied to 20. 1 by 136, it is common for every element, that should be multiplied to every element. Now 9 into 18, 9 18s are 162 minus, you have to multiply 38 and 13. So if you multiply 38 and 13, 3 8s are 24, 2, 2 3, 3 6. So how much we got? It is 114. Finally we got it as 494. What is the result here? 38 into 13 is minus 494, plus into plus plus 37 2s are 74, so it is 740. Okay, this is the result of first element. Now to get second element, we should multiply second row and first column. That is 26 into 18. So when we multiply, we are going to get here 468. So the result is going to be 468. 468, again minus into plus, minus 4 13s are 52. 4 13s are 52. Again minus into plus, minus 14 into 2 28, but 20 we have, so 14 into 20 280, it is minus 280. Now coming to third, 1 into 18 18, then we have 26 into 13, 26 into 13, it is going to be how much? 3 2s are, oh yes, it is 338. We got it as 338. So minus, not minus, plus, plus into plus plus, so plus 338, plus 338 minus 11 into 20 is 220. So now we have to find out the results. We get it as x is equal to 1 by 136 into, when we take first row, it is 162 plus 740 is 902. 902 minus 494. 902 minus 494. When we subtract, we get 8 0, and then here also 4, so it is 408. So we get first element as 408, 408. Now similarly coming to the second one, 468 minus 52 280. 52 280 is 332. 468 minus 332 is 136. Second element is going to be 136. Coming to 13, third element, 18 plus 238, 338. It is going to be 56. 456, 18 plus 338, 356 minus 220, which is 136 again. So like this we got. So that result is 136 should be divided everywhere. So 408 by 136. And the second element 136 by 136. And the third element 136 by 136 again. So what we get here, cancellation, 136 3s are, 136 1s are, again 136 1s are. So we are going to get this matrix as 3 1 1. So x is equal to 3, y is equal to 1, z is equal to 1. So our final solution, x is equal to 3, y is equal to 1, and z is equal to 1. Hope you all understood how to use matrix inversion method to solve given three equations. So it will help you a lot because it is one compulsory question in your board exam. Now here what we did, first we converted all the given three equations into coefficient, variable and constant matrices. Then we found determinant of A. Once if you know determinant of A, we found all the cofactor elements. Once you know cofactor elements, we can write cofactor matrix. Then by using cofactor matrix, we can write adjoint A. We find A inverse is equal to adjoint A by det A. Once we get A inverse, then we find out X is equal to A inverse into B. Like that we get the solution of XYZ. Hope you all understood the solution. Thank you.